Hi, this is Marta with Classes for Teens. Today for a pre-algebra review, we will be talking about properties of numbers. The notes that I will be using are linked below, and when we're finished with this review, please make sure you do the practice problems, which are also linked below, and they include the answers so you can check your work. All right, in mathematics, we have certain properties that we all agree upon and that we have to memorize. So I would go ahead and try to memorize these. One good way to do that is put it on a little flashcard or put them separately on flashcards, the different properties, and test yourself until you know them. The first property is called the commutative property. And when I think of commuting, I think of someone who drives to work, then from work comes home, or drives to swim team practice and then comes home, okay, back and forth commuting. And the commutative property says that if you, for addition, if you add two numbers, it doesn't matter whether you take the 2 plus 3 or the 3 plus 2, you're covering the same distance, right? You're going to get 5, okay? With the multiplication commutative property, it says that when you multiply numbers, 5 times 1 is going to be the same as 1 times 5, right? So the order that you multiply or add is not going to matter. That's the commutative property. Notice that the commutative property does not work for subtraction, and it does not work for division, so don't try to use it there. Then we have the associative property. With associative property, I think of your group of friends or your group of your family. It's the ones that you're associating or grouped with. So notice in the associative property, first we have grouped together the B plus C, and they say that if you group those and do that first with order of operation, you'll get the same thing as if you grouped the A and B together first. So let's check that. Just pick any numbers you want. 1 plus 2 plus 3. And they say if you group these two, it's the same answer as if you group the first two together. Let's check them and see if we believe it. 2 plus 3 is 5. 5 plus 1 is 6. Yep, on that side. 1 plus 2 is 3, and 3 plus 3 is 6. So this associative grouping property works for addition, and it works for multiplication. The next property is the distributive, and I think of this like the postal worker who brings our mail every day in the little postal truck, okay? This distributes, this is multiplying over addition. So A is multiplied to the B, and then A is multiplied to the C. So this notation says that if you add these together and then multiply, you'll get the same result as if you multiply each one and then add. So let me show you an example of that. Let's see. 2 times 1 plus 4 is the same as 2 times 1 and 2 times 4. So you can follow the order of operations here and add those and get 5. 2 times 5 is 10. Or you can work it with the distributing it out. 2 times the 1 and 2 times the 4. 2 times 1 is 2, and 2 times 4 is 8, and 8 plus 2 you can see is 10, okay? So the distributive property is called the distributive property of multiplication over addition, but we call it distributive property for short. Then finally we need to talk about the identity. The identity is what you can either add or multiply, and it won't change things. Your identity is what makes you who you are. Adding a 0 doesn't change anything. So the identity property says if you take a number and you add the additive identity 0, you'll get what you started with. The multiplicative identity is 1. If you take a number, these letters A represent any number that you want to think of. The same thing with B and C. Multiply by 1, and you'll get the number that you started with. 11 times 1 is 11, right? So these are the additive identity is 0, and the multiplicative identity, that's a nice word, isn't it, is 1. Okay. Now let's look at inverse. So inverse is sort of undo things, right? Like a Ziploc bag, you zip it and you unzip it, right? So the inverse of a positive number is a negative number. When we add those together, they add up to 0. So the additive inverse property says that if you add a number to its opposite or its additive inverse, you get 0. So if we'd started with a negative, then we'd have to add a positive to it to make it 0. The inverse is like the opposite. With multiplication, the inverse is like the reciprocal, right? So if you have a number and you put 1 over that number, or you take a fraction and you flip it and multiply them together, you'll be getting a 1. Anything multiplied by its inverse is 1. So that's the inverse property for multiplication. Okay, so I've created some examples here with just symbols, and we're supposed to identify the property which applies to each example. In the first one, I noticed that we start with the blue and then the red and then the green, and they stay in the same order and the same number. What seems to be different is that the parentheses first are around the first two, and here the parentheses have moved around there. So when the parentheses regroup things, look back up at your properties above if you don't have them memorized. That's the associative. Be careful how you abbreviate that. Property of, in this case, it's addition that we're doing. To be honest, most of your teachers are just going to want you to say associative property. They don't care about the of addition, but we're going to put as much as we can, okay? So the next one is, we have a 7 plus 4 in parentheses, and here we have the 3's been multiplied through. So that is the distributive property. And I'm abbreviating these. I hope that doesn't bother you. Okay. And then we have 1 fish followed by a 5, and here we have 5 fish added to 1. So what's happened is the order of them has switched back and forth. That's the commutative property. So this is the commutative property of, in this case, addition. I kind of wish one of these had been multiplication, but oh well, it didn't happen. All right, so let's go ahead with the next set of examples, which kind of shows why we would want to use these properties or know these properties. By knowing these properties, we can apply them and make harder problems easier. So it says to simplify, and you can use your properties to make this an easier problem. 2 times 73, you'd have to think about that or do it out by hand, and then multiply it by 5 would be kind of a mess. But if you rearrange this to be 2 times 5 times 73, it becomes easy. Okay, I did that with the commutative property. I commuted the order of those. I switched it. That was a commutative property of multiplication. Then I take the 2 times 5, which is 10, times 73 is an easy problem, 730, okay? So I used the properties to make it an easier problem. All right, let's try the next one. I guess there are sort of 2 ways to make this easier. I noticed that 5 times 5 is 25, and 25 times 4 is 100, so that's what I'm going to do. You could also do 5 times 4 is 20, times 5 is 100, and then multiply by 67. Okay, so there are 2 good ways to do this. There's only one correct answer. I'm going to do the way that occurred to me, and that was to take the 5 times the 5 times the 4, and then the 67. I don't know why I added parentheses instead of dots. Doesn't really matter. It's just notation. Now, why did I drop off the negatives? Well, negative times negative makes it positive, so I just threw it out already, okay? 5 times 5 is 25, times the 4, times the 67. 25 times 4 is 100, times the 67. And 100 times 67 is 67, followed by 2 zeros. Okay, so there was at least one other really pretty good way to do this. Your teacher isn't going to care as long as you show your work and they can tell where you came up with your answer. Okay. All right, the last one is fractions. Blech. No one likes those. Well, I don't mind them, but most students don't like them. Try and tip this camera a little bit better. Okay, so what I noticed is I had a negative 3/5 and a positive 3/5, and those go nicely together. So I'm going to take the positive 3/5 and the negative 3/5, put those together because they make a 0. Then I'll do this other mess. And I noticed that they didn't have the same denominator, and that I'm like, oh no, we got to get an LCD. But we don't even have to do that because This makes a 0, right? Anything minus the same thing as a 0. And then we have 7/8 plus 9/8, which gives me 16/8. And 16/8 is the same as 2. Yep, 16 divided by 8 is 2. Circle your answer. All right, let's go to the next few. And these are having us do the properties. And we could get carried away here, but we won't. We'll just do what they say. Decide whether the statement is an example of the commutative, that's back and forth, associative, that's a grouping, identity, that's stuff that you add or subtract, it doesn't change, inverse, that makes it add up to 0 or 1, depending on multiplication or addition, and I said that backwards, I think, or the distributive property. So here I have a number and its opposite that add up to a 0. So that property is, look above if you have it memorized, a number plus the opposite in this addition. So this is the inverse property for addition. If you wanted to add that, but I didn't because it just asked for inverse. All right, let's try the next one. A number times 1 is the same number. 4 times 1 is 4. That is the identity property. Now, it's actually the identity property for multiplication, but again, they didn't ask me that, so I'm not going to set it down. Okay, I'm not going to add it. Here I have a number 8/5, and then I'm multiplying by the reciprocal, which means we flipped it upside down, 5/8, which is going to give me 40 over 40, which is 1. That is a number and its reciprocal, which would be the inverse property being illustrated for multiplication in this case. And the last one. We have 8 times 4 times 1, 8 times 4 times 1. I noticed that they're in the same order, so there's no commuting happening. But I do notice that the parentheses have moved. They were grouped here and then grouped there. When things are regrouped, it's the associative property. And this would specifically be the associative property of addition. But again, they didn't ask us that. Okay, make sure you do your practice homework and check your answers. Thank you.